Hello everyone, my name is Zhongzhi Yu from Georgia Tech ESC Lab, advised by Dr. Yunyan Lin. Today I'm going to introduce our work called Unveiling and Harnessing Hidden Attention Sinks, Enhancing Large Language Model Without Training Through Attention Calibration. This work is published in ICML 2024 and collaborated with Zhengwang Yong'an Fu, Guihong Shi, Khaled Shakai. In recent days, people observe that in LLMs, there are some tokens attract excessively high attention, and the previous work, specifically streaming LLM, mentioned it as attention sink. And in streaming LLM, they observe that attention sink is only observed in the initial token, and it helps LLM inference by preserving attention distribution so that it can maintain its stable performance even when generating long context that has not been previously observed during the pre-training or fine-tuning stage. However, in this paper, we're wondering is this all about the attention sink phenomenon in large language models? And in this paper, we try to answer the following three research questions. First, do attention sinks only exist in initial tokens? Second, do all attention sinks help with large language models performance? And third, can modifying attention sinks boost large language model? To answer the first question on do attention sinks only exist in initial tokens, we perform extensive visualization of attention map from different LLMs using different inputs. As shown in the figure below, by using Llama 2 7B instruct model and feed it with multiple different inputs from different datasets, we observe that there are multiple attention sinks in large language models, as shown in the darker red column in the attention map. Further, by using a more fine-grained visualization to visualize the layer-wise attention maps, we found that during the intermediate layers of large language models, these types of attention sink in later tokens are particularly commonly observed in attention maps. Also, by visualizing the attention score distribution across the original initial attention sink tokens previously observed by streaming LLM, which is shown as the blue part, and the other tokens that are not attention sink, which is red part, and also the yellow part, which corresponds to non-initial attention sink tokens. They actually has really distinct attention score distribution across each other, showing that this kind of attention sinks in later tokens is a new type of attention sink. Given its distinct distribution in attention scores, a natural question to follow up is that although the previous streaming alarm showed that attention sink initial token help with performance, does all attention sinks still help with LLM? And we realize the token that extracts attention that attracts attention sink. And we find that in later attention sinks, it mainly appears in tokens with less semantic information, such as some symbols like period or comma, and also some special tokens. This kind of behavior on excessively using a lot of attention to tokens with less semantic information intuitively does not really help with the performance. So to answer this question, our we perform an ablation study and find that not all attention sinks are beneficial for LLMs. Actually, most attention sinks in middle or later parts of the input hurts the LLM's performance. Specifically, as shown in the red figure below, we remove the later attention sink token attention value and redistribute it to other tokens in each of the attention head across in each layers in a large language model and show the evaluation score change before and after we do this modification to each head at each layer in large language model. And in this figure, the x-axis is the height ID, the y-axis is the layer ID, and uh, and elements with a warmer color indicates a higher accuracy improvement after removing the excessive attention values at some specific attention sink, and elements with a colder color indicates there are a larger accuracy drop after we remove the attention sink in later tokens. And we found that for the majority of attention heads in later layers, change the or remove the excessive attention in later attention sinks actually help with the performance, indicating that at least the majority of attention heads in a large language model does not need this kind of attention sink happens in later tokens. And motivated by this observation, we try to answer like, can we modify attention sinks to boost the accuracy of large language model? And to this end, we propose attention calibration technique, where we select a set of ineffective heads for each large language model using a held-out small-scale calibration dataset. And then we reduce the attention of attention sinks in later tokens in the selected heads and redistribute the redundant attention to other tokens. As shown in the figure below, the left part is the attention map before attention calibration, and the right part is the attention map after calibration. This kind of endeavor actually develops a training-free, on-the-fly technique to calibrate the attention and aims to improve the performance of large language model during inference on the fly. And to evaluate our proposed method, we evaluate across over 10 different data sets across 3 tasks, including multi-round conversation, classification, and language understanding. We found that using by simply calibrate attention, it actually achieves up to a 7.3% improvement in accuracy compared with vanilla inference. Further, we found that even on a challenging multi-round conversation dataset, MT bench, calibrating attention reduces the performance gap between smaller and larger Llama 2 model by 33%, showing its promising capability on improving the performance of large language model without any training on the fly, during inference on the fly. And here is our paper, Unveiling and Harnessing Hidden Attention Sinks, enhancing large language models without training through attention calibration. And if you want to know more about our work, please feel free to scan the QR code below to refer to our project page, which has more information as well as experiment results, and also our source code to reproduce or follow up our research. Thank you for your time.